radian measure. We're about to just learn or relearn everything we just did, but instead of using degrees, we're going to now learn it all with radians. So rather than thinking of angles on the inside of a circle, which is what we call degrees, we're now going to be thinking of the distance around the outside of the circle, and that is going to be radians. So the distance around the outside of a circle, well, that is circumference. And you can see here we've written circumference. Circumference is the distance all the way around, except that when we drew these, remember how we would kind of draw these things like this, and we would say 30, 45, 60, and whatever, we would fill out this whole thing. Remember that this point was 1, 0, this was 0, 1, negative 1, 0, 0, negative 1, meaning this distance from here to here was go over 1, up nothing, go over 1. That means that this distance here was 1, and 1 is our radius of a circle, which is why we call this a 1 unit circle. Now, we don't ever say the 1, we just call it a unit circle. So the radius is 1. So if you think of the circumference is 2 pi times the radius, but the radius is 1. Then we say that the circumference is just 2 pi. So the distance around is 2 pi radians. That is how one full circle is 2 pi radians. Compared to degrees, we say there's 360 degrees inside the circle. Here we say there's 2 pi radians on the outside. So 2 pi by the radians, by the way, is around 6.3, 6.28 or something. So that's what that is. 2 pi is around 6.3 radians. So it takes 6.3 radians to go all the way around. Okay? That is somewhat complicated, but it makes a little bit more sense here when we actually do some converting. So one of the things that we want to do is we want to find an easy way to convert to radians, and then also, if we're in radians, to convert back to degrees. It's very much like, we measure things in centimeters, but then we're also measuring something in inches. And so centimeters and inches, I think it's like centimeters is metric and this is imperial or something like that. There's going to be some sort of conversion factor. So I told you before that we could say 2 pi radians as the same as 360 degrees. All the way around the outside is the same thing as 360 degrees. But there's too many numbers here, so we can divide them both by 2. So that becomes just a pi, and this becomes a 180. So this ends up becoming our conversion factor. Pi radians is the same thing as 180 degrees. That's going to be really important. So maybe we should write that. Oh, we did. Pi radians is the same thing as 180 degrees. So that is really important. That's how we're going to convert things. And it's actually very straightforward. So let's take 30 degrees. Here, let's do the first one. And if you want to convert to radians, you need to have the radians. I think in science you do this, where you end up putting what you want up top and what you want to get rid of on the bottom. So I want to get rid of degrees, so I'm going to put degrees on the bottom. And with degrees goes the 180. And then here would be the pi radians. Okay, so, the pi radians is the same thing as 180 degrees. The degree symbols can cancel out. So now you've got 30 times pi, so that's 30 pi radians over 180. Used to be degrees, but the degrees are canceled out. Now the top and bottom can both be they can both be divided by, 3, 6, 10, so it can be 30. So they can both be divided by 30, so this will just become a pi, and this will become a 6. So we say that 30 degrees is the same thing as pi over 6 radians. That's really important. So let's try another one. We're at 45 degrees. That's the same thing as going, let's write it down, 45 degrees You want to get rid of degrees, throw them on the bottom. That way the degree symbols will cancel. Now with the degrees has to go to 180. And up here has to go to pi radians. So I'm not going to write radians. No one ever really writes that. So we're just going to leave it as pi. So on the top I got 45 times pi, which is 45 pi over 180. So this could be divided by 9. In fact, both of these can be divided by 45. So 45 divided by 45 is just going to leave you with a pi. Now 45 goes into 180 4 times. So it's pi over 4 radians. But again, we don't write the radians. So we say 45 degrees is the same thing as pi over 4. Let's continue on here at 60 here. So we have negative 60 degrees. And we want to get rid of degrees. So degrees will go on the bottom. And we want to go to radians. So 180 goes here and pi goes here. Again, we don't write the radians. So top and bottom. So tops go negative 60 pi. And the denominator is just 180. The degree symbols have now canceled. Now both those can be divided by 60. I'll write it over here actually, divided by 60. And you're going to just get a pi and you're just going to have a 3. And that's it. So negative pi over 3 radians. We can continue on here. 360 degrees. We want to get rid of degrees. Put them on the bottom. So I'm going to put the 180 with a degree. And then the pi radians on top. Just write pi. And then the numerators can go together. And so I have 360 times pi. Sorry about that. It is going to be 360 pi. And the bottom is 180. Those can cancel. And then 360 and 180, both those can be divided by 180. So the top, if it's divided by 180, is just going to be a 2, and there's a pi. And 180 over 180 divided by 180 is just 1, so that's gone. So the answer is 2 pi radians. So I'll zoom out here so you can see these 4 questions. In the next video, we'll do the next 4 of them. And then we'll convert because we're going to radians here, we're going to convert to degrees.